Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So we have done chapter 2.1, derivative of a function, in which at the moment you should be able to find the derivative of a function by using the first principles. Okay, so now we are going to move to chapter 2.2, techniques of differentiation. All right, so at the end of this subtopic 2.2, okay, you should be able to use the basic rules of differentiation. So use the sum, product, and quotient rules. Use the chain rule. So find the derivative of the combinations using sum, product, quotient rules, and chain rule. And last but not least, find the second derivative. Okay, so let us start discuss the first techniques of differentiation, in which we have three basic rules of differentiation. Okay, so the first one is differentiate a constant. The next one is differentiate the power of x. The third one is differentiate a constant multiple. So these three cases are under the basic rules of differentiation. Okay, so let us discuss the first one, differentiate a constant. So it's stated here, suppose fx is equal to any constant. Okay, so let's say k. So f prime x is equals to 0. Okay, so for example, suppose that we have, let's say we have fx is equals to, let's say 11. Okay, so the f prime x of our fx here, since we have a constant and we don't have any unknown that is being attached to the constant, so it's just equals to 0. Okay, suppose that we have another example, fx equals to, let's say, ln 3. Okay, so ln 3 is actually a constant. It's not the function that we have x attached to it. Okay, suppose when you try to get the value by using your calculator, you should obtain decimals. Okay, so differentiating ln 3, as it is also a constant, should give you equals to 0. All right, so let us move to the second case of under basic rules of differentiation, where we need to differentiate the power of x. Okay, so the formula is basically, suppose that we have fx equals to x to the power of n. Okay, so f prime x is just we bring down the power next to the x. Okay, so we will write back the x, and the power is being minus by 1. Okay, so let us start with the first example. Suppose that we have, let's say, fx is equals to x to the power of 5. Okay, so according to the formula, to differentiate the power of x, which is we need to f prime x, so we need to bring down the power here. Okay, so copy back the x, and the power of 5 will be minus by 1, so that we should get 5x to the power of 4. Okay, so let's say we have now fx, which is equals to square root of x. Okay, so we know that square root of x is actually equals to x to the power of 1 over 2. Okay, so which is therefore the f prime x here is equals to, so bring down the power first, we need to bring down the 1 over 2, and copy back the x, and the power where it was 1 over 2, now it's being minus by 1, so 1 over 2, you take away 1, should give you negative of 1 over 2. Okay, so we can just leave the answers just like that, or even if we want to make it positive, I should write it as 1 over x to the power of 1 over 2 like this. Okay, so then eventually it will be 1 over 2 times x to the power of 1 over 2, or can also be written as 1 over 2 third x like this. Okay, well, it's not third, it is 1 over 2 square root of x. That is even better. All right, so let us give you one more example. Suppose that we need to differentiate fx, which is equals to x. Okay, so suppose that we have fx equals to x, like this example. I'm going to move it a little bit here. Okay, so x is originally to the power of 1. Okay, and suppose if we want to find the derivative, so basically we bring down the power, so copy back the x, and the power of 1 will be minus by 1, so 1 minus 1 should give you 0. So we know that anything which is to the power of 0 should give you 1. Okay, so basically, so differentiating x should give us just constant 1. All right, so the next one, under basic rules of differentiation. Okay, so we have the case of differentiate a constant multiple, so which is almost similar to the differentiate the power of x, but we do have a constant in front of the function. Okay, so but the step is just the same thing, where we will bring down the power, and the power will be multiplied with the constant, and the power will be minus by 1. Okay, so let us, for example, we have this kind of function fx equals to 4x to the power of 5 here. Okay, suppose when we need to find the f prime x, well, basically when you look at only this x power of 5, so we have the power of x here. Okay, but we have the constant right now, so I'm going to write so bring down the power of 5, so times with 4, copy back the x, and the power of 5 will be minus by 1, so that we should get 4 here, so which is eventually it is 20x to the power of 4. All right, so let's say we have now fx is equals to 3x to the power of negative 4. So this one is also under the case of differentiate a constant multiple, because we do have constant in front of the power of x here. Okay, so but the step is absolutely the same. So f prime x here is just, we should write the bring down the power negative 4, so times 3, copy back the x, and the power of negative 4 will be minus by 1. Please be very careful, negative 4 minus 1 is negative 5 here, so which is eventually we should get negative 12x to the power of negative 5, or even if you would like to make the power positive, so it can be negative 12 over x to the power of 5.